Hey there, and welcome. Today, we are going to peel back the layers on one of the most important programming languages ever created, C. We're going to deconstruct it, go from the actual code you see on a screen to the big ideas that make it so incredibly powerful.
So here's our game plan. First, we'll get into what C actually is. Then, we'll check out its building blocks, kind of like its alphabet and vocabulary. After that, we'll see how to make code actually think, explore the art of planning, and finally, wrap it all up to see how a simple idea can turn into a real working solution. Okay, let's jump right in. First up, what is the C language? You can really think of it as the blueprint for so much of the modern programming world. Let's start with the most basic question of all. We hear the term programming language all the time, but what is it, really? Well, it's just a formal way for us to give instructions to a computer. And C is one of the granddaddies of them all. Its story starts way back in 1972 with a guy named Dennis Ritchie at the legendary AT&T's Bell Labs. Then, to make sure everyone was speaking the same dialect of C, a standard was set in 1983, and that just led to this massive boom in the 90s. Its influence from that era is, believe me, still everywhere today.
Now here's where it gets really interesting. C is what we call a middle-level language. It's not super abstract and human-like, say like Python, but it's also not low-level, like raw machine code. It sits right in that sweet spot, giving you the best of both worlds. You get syntax that's easy enough for humans to read, but with powerful, close-to-the-metal control. That just means you can work more directly with the computer's hardware, which gives you incredible speed and efficiency.
All right, so now that we've got a handle on what C is, let's actually learn how to speak it. On to our next section, the building blocks. Think of this as learning the alphabet and the core vocabulary of our new language.
Every language has to start with an alphabet, right? C is no different. It understands uppercase and lowercase letters, the digits 0 through 9, and a whole bunch of special symbols. These are the most basic characters that C will even recognize.
So if those are the letters, what about the words? You might be expecting some huge, intimidating dictionary, but this is one of the most beautiful things about C. It has only 32 key words. That's it, just 32 special words. It's a surprisingly small number, isn't it?
And here they all are. These are the reserved words. They have a very special meaning to the C compiler. You've got words like if, else, for, and while. These are the absolute core you'll use to build any kind of logic. Now, don't worry about memorizing them all right now, but it's pretty amazing to see the entire core vocabulary of the language fit right on one slide.
And of course, a language isn't much use without grammar. In C, the rules are super clear. First, every statement, every complete thought ends with a semicolon. Just think of it like a period at the end of a sentence. Second, C is case-sensitive, which means counter with a lowercase c and counter in all caps are two totally different things to the computer. Third, all those keywords we just saw, they're always lowercase. And a big one, you have to declare your variables before you use them. That just means you have to tell C what kind of information you plan on storing ahead of time.
So, we've got the alphabet, we've got the vocabulary, and we've got the grammar. Now it's time to actually make our code think. So let's dive into Section 3, Controlling Program Flow. This is absolutely crucial. Without control structures, a program would just be a dumb list of instructions. It would run from top to bottom, one line after another, and then just stop. Control structures are what give it life. They let it make choices, react to different situations, and do repetitive things without you having to write the same code over and over. It's really the difference between a simple checklist and an actual brain. And C basically gives us two main tools for this. First, you've got conditional statements. These use keywords like if to make a choice. If it's raining, take an umbrella. Otherwise, do something else. Simple. Second, we have looping structures. These use words like for and while to repeat a chunk of code over and over again, which is incredibly powerful. Okay, so knowing all the words in the grammar of C is one thing, but knowing how to actually use them to solve a real problem, that's a whole different ballgame. And this brings us to what I think is the most important part of programming, the art of problem solving, or as I like to call it, the architect's plan.
Before you ever write a single line of code, you need a plan, and that plan is called an algorithm. I want you to forget about code for just a second. This is all about pure logic. An algorithm is the step-by-step recipe you create to solve your problem, written in just plain English. If you can get the recipe right, the actual cooking, or in our case, the coding, becomes so much easier.
So if the algorithm is your recipe written out as text, then a flowchart is like the diagram of that recipe. It uses standard shapes and arrows to map out the entire flow of logic, all the decisions, all the loops. It's just a fantastic way to visualize how your program is going to work before you get bogged down in the details of the code.
And this slide really breaks down the difference perfectly. An algorithm is text-based, step-by-step instructions. It's great for getting into the nitty-gritty details. A flowchart, on the other hand, is a visual, block-by-block diagram. It's much more intuitive, making it way easier to see the big picture and how all the different parts of your program connect. Honestly, both are essential tools in a programmer's toolkit.
Okay, let's bring all of this home. We've got the language, we've got the logic, and we've got the planning tools. So let's move on to our final section and see how we go all the way from just a basic idea to a fully formed solution.
And this right here maps out the entire journey. And I want you to notice something really important. Implement the solution. That's the part where you actually write the code, is step 5. The real work, the bulk of the work, is in the thinking, defining the problem, gathering info, brainstorming solutions. Programming is really a discipline of thought that's just expressed through code.
And this quote just says it all, doesn't it? It's not about memorizing 32 keywords. It's about developing a whole new way to think, critically, creatively, using these powerful concepts we've been talking about. The code is just the final expression of a really well thought out solution.
So we've gone from the basic alphabet of C all the way to a universal framework for solving problems. We've seen that behind every piece of software, there's a concept, a plan, an algorithm. So the question I want to leave you with is this. Now that you know what the building blocks are, what kinds of problems would you want to solve? What would you